A particle P of mass 0.3 kilograms is projected upwards along a line of greatest slope from the foot of the plane inclined at 30 degrees to the horizontal. The initial speed of P is 4 meters per second and the coefficient of friction is 0.15. The particle P comes to instantaneous rest before it reaches the top of the plane. Calculate the distance P moves up the plane. Find the time taken by P to return from its highest position on the plane to the foot of the plane. Calculate the change in the momentum of P between the instant that P leaves the foot of the plane and the instant that P returns to the foot of the plane. So here's the question here in summary form then with the picture. P, the mass is 0.3, the coefficient of friction is 0.15. It's projected up at 4 meters per second. So the weight will act vertically down, will be 0.3 g. Then it will have, as it goes up, it will have a resistant force here of mu r. Okay, and it will go up with an acceleration up the plane with an acceleration a. And it starts off at 4 meters per second. We'll go up, we'll come to an instantaneous rest here before it starts to roll back, slide back down. So the first thing is, how far does P travel up the plane? So let's look at that then. So let's resolve the forces along this way for part 1. So first of all, there's no acceleration in this direction. So R is equal to the other force in the other direction. This is 30, this is 60, so this is 30. 0.3 g or 3/10 g times cos 30, which is root 3 over 2. So there's R. Now if we go up the plane and apply F equals ma then, we've got minus mu R. 0.15 is mu, which is 3/10. Minus mu times R, 3g root 3 over 20. That's minus mu R. Minus this force here, which is 0.3 g, 3/10 g again. Cos 60, which is a half, is equal to, these are the forces, mass 0.3 or 3/10 times the acceleration. So the 3/10 will cancel all the way through, and that will tell us what the acceleration is. Once we find the acceleration, we can find the, we know the initial speed, we'll be able to find the distance. So what have we got here? We've got a minus, we've got a g over 20 as common, g over 20 here, so that's 1 here, plus the other term, it's going to be 3 root 3. G over 20 was taken out and we just had a 3 root 3. So that's equal to then minus g over 20. So I'm going to drop the minus, I'll put it in a moment. 9.8 divided by 20 times by bracket 1 plus 3 times the square root of 3. Close bracket equals 3.036 with a minus. So there it is there, which is equal to minus 3.04 ms minus 2, and that's the 3 significant figures, isn't it? Okay, that's the acceleration then. Now we know the initial speed, so we can get the distance now, can't we? Because the final speed when it comes to rest is 0. So v squared equals u squared plus 2as. Let's apply that then, invoke that formula, gives. So 0 will equal the initial speed, 4 squared, which is 16, plus 2a, 2 of these, times s. 2a, so the minus I brought here, haven't I? I've taken it through to the front. So that tells us that s is equal to, so move this, all this over there, and it'll leave the 16, and then the number that's beside the s can move down to divide, which is 2 times 3.04, which we have in the calculator. So this is the number, times by 2, equals, now that's the number underneath, so 16 divided by the number underneath, which is the ants now in memory, is 2.6349. 2.6349, which equals 2.635 meters. And that's the 3SF. 2.635 meters. A particle P of mass 0.3 kilograms is projected upwards along a line of greatest slope from the foot of a plane inclined at 30 degrees to the horizontal. The initial speed of P is 4 meters per second and the coefficient of friction is 0.15. The particle P comes to an instantaneous rest before it reaches the top of the plane. Calculate the distance P moves up the plane. Find the time taken by P to return from its highest position on the plane to the foot of the plane. Calculate the change in the momentum of P between the instant that P leaves the foot of the plane and the instant that P returns to the foot of the plane. So, here's the question, and I've summarized it here. I've drawn a normal in and a reaction. The weight of P is mg, which is 0.3 g. So this is 30, this is 60, this will be 30, won't it? So if we resolve forces that way, then we'll get the reaction. R is equal to 0.3 g times cos 30, which is root 3 over 2. So let's get the reaction force then. 0.3 times 9.8 times by the square root of 3 divided by 2 is 2.54611. 2.54611. So there's the reaction force, newtons. Okay, we've got that nice and accurate now. Now we will resolve forces along the line of greatest slope. So we've got a resistance force here, mu r. So it's minus mu, 0.15, times the reaction force, 54611, minus mu r, minus 0.3 g, cos 60 is sine 30 as a half, is equal to the mass, 0.3 times the acceleration. So that tells us then that 0.3a is equal to this number here. So let's tap that in the calculator. So we got that number, we times that by minus 0.15 times by 0.15 with a negative, just bear in mind it's negative, and then we've got another negative here, so let's add this, plus 0.3 times g divided by 2. Don't forget that whole thing is negative. 1.85 and divide that by 0.3. 6.17. So 6.17 is what we get for the acceleration here. So I've already divided by 0.13. So it's 6.17305. So that's the acceleration then, meters per second squared. So now we know the acceleration, we can use v squared because it gets to the top of the plane and stops instantaneously. So v squared is u squared plus 2as. Oh yeah, that was negative, wasn't it? So that we can find the distance here now. Gives. So v squared is 0 squared, which is 0. U squared, u is 4, so that's 16. Plus 2as. So bring the minus out. 2 of these. 6.17305. Times the distance s. So that tells us that s is equal to, then move this over there and we get 16, and then move the number of s's underneath. 2 times 6.17305 is equal to, so times this number by 2, and that's now in the answer. 16 divided by answer then. 1.2959. 1.2959, which equals 1.3 meters and 1.30 meters, and that's the three significant figures. So there's the distance it moves up the slope then and comes to instantaneous rest. So that's part 1 done. Now part 2. So it comes to stop there at that distance. Find the time taken to return. So it comes to stop here. It's got its weight still acting on it, 0.3 g. The mu is now going to act against the motion. It's still got its reaction force here the same. So R will still equal that. So coming down the plane then, part 2. Here, R will still be the same. So I'm just going to copy that down. 54611. Newtons. And that's the reaction force. Now applying F equals ma downward down the slope then. Let's go down. Apply F equals ma. So you've got mu r, so it's 0.15 times this reaction force, 54611, plus the component of force, 0.3, the weight, times its component cos 60, isn't it? Which is over 2. So it's plus this time. Let's just show you that on the picture. This weight, cos of this angle, 60, plus, it's that minus mu r, isn't it? So the mu r is negative, plus the weight is equal to the 0.3 times the new acceleration now, which we can call a dashed. Okay, so let's tap that in the calculator then. I've got, so I'm going to move this and just add them up together. So it's 2.54611. (54611) times negative 0.15 equals, so I've got that number. Now let's add on 0.3 times 9.8 divided by 2 equals, that's this number, and divide that by 0.3 divided by 0.3, 3.6269. So that tells us a dashed is equal to 3.6269 meters per second squared. There's a dashed. Yep, that's fine. So there's the acceleration going down the slope. We know the distance is 1.2959 is the distance, so we can get the final velocity. We need the time taken though, don't we? So S equals ut, the initial velocity is 0, plus half at squared. So that's 0. So this was 1.29. So using this formula gives S is 1.2959 is equal to a half times the acceleration, 3.6269, times t squared. So t squared will equal 2 of these divided by this number, won't it? 3.6269. And then I'm going to square root both sides, so I'll do that here in this single line. Let's tap that in to get the time. Now I've got this number here, so that's the answer now, isn't it? So 2 times 1.2959 divided by the answer equals, and then square root the answer, square root ants, equals 0.84533. So that's equal to 0.845 seconds to 3 significant figures. So there's the time it takes to descend to the bottom. We know the acceleration, so we should be able to get the final velocity now, where it comes back to the bottom. So let's use v equals u plus at. Apply that, gives Well, the velocity is v, the initial speed is 0, acceleration is equal to 3.6269, and the time is 0.84533, which we have in the calculator, equals, so we just got to times that by times by 3.6269 equals 3.0659. 3.0659. So finally then the change in momentum. So I'll put it up here in this little space here. Change in momentum is equal to, because that's what the question asks for at the end, calculate the change in momentum before it was at the beginning. So this change in velocity is equal to this, minus 4. So 4. Oh no, it's going in a different direction, isn't it? So it goes up and then down. So it's 4 plus 3.0659 multiplied by the mass, which is 0.3. So there's our what we need to do then. So add 4 to this, plus 4 equals, times by 0.3 is 2.1197, which is 2.1197, wasn't it? 1197, which equals 2.12 kilograms meters per second. And that's the three significant figures.